So we saw that we're going to talk about approximating a continuum by triangles, and we're going to need a few useful facts about triangles. These are not particularly deep or anything, just some facts. So here's a triangle with the vertices numbered 1 to 3. Notice that they're numbered in a counterclockwise direction. See if you can follow the area calculation below and explain why it's better to number the vertices in a counterclockwise direction. So first we compute the area of the triangle. So the area is um, from the geometry, 1/2 of the side 1, 2 times the side 1, 3 times the sine of the angle theta. And this is nothing but 1/2 the length of the cross product of the vector 1, 2 and the vector 1, 3, which we can write as this determinant. Now doing some elementary row and column operations. So for example, we're adding row 1 to row 2 and row 1 to row 3. This determinant can be written like this. And then doing an elementary column operation where we're adding x1 times column 3 to column 1, then x1 times column 3 to column 2. We can write the determinant like this. And then we can do a cyclic permutation of the columns to get a very nice looking formula for the area. So the area is 1/2 of the determinant of 1, 1, 1, x1, x2, x3, y1, y2, y3. Now another set of facts has to do with the lengths of the sides and the normal vectors to the sides, unit normal vectors to the sides. So for example, if we take the unit normal to the side opposite the vertex 1, which we'll call n1, we can compute that unit normal by doing this cross product and then dividing by the length. So we're taking the cross product and then dividing it by the length. And the length of that side itself is the square root of x2 minus x3 squared plus y2 minus y3 squared. So we see that n1, l1 is this vector. Similarly, we get n2, l2 is this vector, and n3, l3 is this vector. And we notice that n1, l1 plus n2, l2 plus n3, l3 is 0. And we'll use the area formula as well as this formula with normals and lengths in subsequent calculations.